taste of water and also promote the odor. And for the oxidation of iron and manganese, hydrogen sulfide add a limited extent of organic matter. And sometimes the substances that alter the characteristics of water in preparation for a subsequent processing step, especially in recarbonation process after softening with excess lime. This carbon dioxide is added by an aeration device for the neutralization of caution. This carbon dioxide is added at times during aeration to water high in sulfide in order to lower the pH value and thereby increase the volatility of hydrogen sulfide for more effective removal from the water during this process. So this aeration process has some limitation also. What are the limitations? Actually, when the substances can be removed by aeration, when the volatility is adequate. But generally, it is not an efficient method for removal or reduction of unpleasant taste or odor because most of the substances causing the undecided rise are not sufficiently volatile matter. This non-volatile matter, how could be removed? That cannot be removed by this aeration process. That is one of the drawback of this aeration process. The organic disintegrate and release essential oils of algae which are not highly volatile. That also cannot be removed satisfactorily by this aeration process alone. Sometimes the odor caused by cyanura only 50% can be removed. When iron and manganese are present along with organic matter, moderate rather than vigorous aeration gives better result. Otherwise, normal aeration process will not remove that. The next important, then this is important question. The people will ask what is meant by aeration. What are the limitations of aeration and the theory of aeration? The theory of aeration, which I am going to explain, is one of the important questions. Without that question, you can't see any question before. I will say what is meant by theory of aeration. People are there. Are you hearing me?
Yes, ma'am. Yes, ma'am. Allowing the air into the water, ma'am.
130 to 3 class, it is not useful to you people, I feel. If you want us to give some gap between 130 to 2 for lunch means, we will provide next class onwards. Are you suggesting like that? Hey, people, you just respond to me in any way.
Okay, ma'am.
Can I tell to the top management like that?
Yes, ma'am.
Okay, it is difficult for all of you to sit.
Okay, ma'am.
Okay. If people start interact, then your sleep will go. The theory of aeration. What is meant by theory of aeration? Actually, aeration is very important process in water treatment technology. Actually, substances that occur in water, whatever it may be the substance, that amount is less than or excess than their saturation value means they change their concentration by aeration process. With that saturation value being the limit for change both the condition, that is both the side, forward side and backward sides. The substance involved in the reaction must be volatile because this aeration process will remove only volatile substances. This oxygen, carbon dioxide and hydrogen sulfide are volatile and their concentration in water are readily affected by the aeration process. So this aeration for the removal of volatile material is more effective in warm water than the cold water. Removal by aeration of some gases such as hydrogen sulfide, carbon dioxide, methane is strongly dependent upon the pH of water. Lower pH value improve efficiency of aeration than higher pH value. That is acidic pH value work out. The interchange of the substances from water to air or from air to water takes place at the air-water interface only. The rate at which the interchange occurs is a result of the relative concentration of the substances at the interface and the rapidity of change of these interfaces, which new surfaces are formed and exposed to the interchange. If the gas exchanges is described with the help of following example, If gas is absorbed during the process, then they have given one equation. If the gas is released during the process, they have given some expression. From the expression, Ct equal to, for gas absorption, Ct equal to Cs minus C0 10 to the power minus K by V into T. That means here where Ct is the concentration at time T during the process at any time, Cs is the saturation concentration of the gases, C0 is the initial concentration of the gases, A by V is the ratio of exposed area to the volume of water, K is the gas transfer constant, T is time of exposure. The same expression when it is released, the saturation concentration will be added with the expression. When gas absorption, gas saturation value will be subtracted with the expression, which means that when it's something is absorbed, heat is released. When something is released, the heat is released. So the positive negative effect is expressed for absorption and release cases. Next one is design of aerators. The design of aerator is very important. There are many types of aerators are available. Based on the type, we have to choose for our purpose. Aerator should be designed to provide the maximum surface area we have to provide to spread the atmosphere and the water. When the interaction between the atmospheric air and the water surface is more, means the efficiency of aeration process will be good. To provide agitation to aid diffusion and to ensure free flow of atmosphere to remove gases and volatile substances liberated from the water. Aerator in general, they have classified into three categories. One is gravity type, second one is diffused air type, and the third one is spray type. Among these three types, gravity type and diffused air type people mainly are used for aeration process. And this gravity type, what is meant by gravity type? Gravity type of aerator is that have a gravity fall of water, nothing more than that. In gravity fall of water, what is happening? The water flows down the steps or trays, that is in the form of thin sheet providing a large water surface and creating agitation. Many experience has shown that waterfall type aerator should have an area of 0.02 to 0.05 meters square per meter cube per hour surface area, which removes the carbon dioxide is about 30 to 60% and the addition of oxygen is required or adequate. The gravity type of aerator is being again classified into cascade type aerator and multiple tray aerator. And the third one is rectangular aerator. This cascade type aerator, which is very easy to explain, which consists of steps or trays, which are arranged in the structure 1.2 to 3 meter height, which is normally consisting of 4 to 6 steps on trays, although maximum number of steps could be more than 10 only, not more than that. In fact, more number of steps improve the process. The rise and tread of each step is normally 20 to 30 centimeter gap. The steps could be surfaced with the glazed tiles to minimize the problem of sling formation and algal growth. Actually, the collecting channel they will provide at the bottom. There, the velocity of the water is supposed to be maintained very less, 2 meters per second only. When they are using this kind of water, the time fall through the height will be calculated by 2h g to the power half. If they are using n number of trays, they find out the time by 2 nh by g whole to the power half. From that, how long it takes to treat the water. The treatment is depending upon the number of steps is being used. If more number is used, if the exposure more area to the atmosphere, then the aeration will be better. Multiple tray aerator, here what people are doing, the space requirement for this type is less than this, since the area exposure for each tray available is up to the internal pipe or inlet pipe, with just not this kind of step. So here the area is more. They have given some expression for area available for aeration process, that is equal to pi by 4 into they have given in the form of 4d squared, but if we are using n number of pipe means that is the expression they are given for diameter calculation. If they use a rectangular aerator means, this also again be classified either cascade type or inclined apron type. The cascade type, what I have mentioned last, like that only. It consists of number of steps, and it is consisting distributing channel at the top and a collecting channel at the bottom. The remaining functioning of this type is similar to the cascade type, what I have explained. And another one is inclined apron type. Here, the apron is usually studded with the ripple plates. It is something like a set of plates. And the planes in a honeycomb fashion, it is being provided, which makes or breaking up the sheets of water that would otherwise form like a thin sheets. In the absence of a ripple plate, apron would be studded with stones forming a honeycomb structure, so which will expose more surface area of water into the atmosphere. Then the proper aeration will take place. The advantage of rectangular aerator is that it is extension is easily possible at the time of scaling. Next one is stacks of perforated pans or tubs. In this particular type, a number of trays, normally 3 to 6 in number. They are all perforated trays at the bottom with small holes, or bottom with a slats, or bottom with wire mesh they are using in this case. The trays are provided or filled with inert content material like gravel, slag, coke, ceramic balls of size 50 millimeter to 150 millimeter. The depth of this inert material is, each tray normally varies from 20 to 40 centimeter, and the spacing between the trays supposed to be 30 to 75 centimeter, and the space recommended in general 2.4 to 12 meter cube per hour per meter square of total tray area. The efficiency of aerator in terms of carbon dioxide removal is 65 to 90%. And this is very good answer. The removal of carbon dioxide can be expressed by using some carbon dioxide concentration related formula, that is Cm equal to C0 into 10 to the minus 8. That is concentrations of carbon dioxide after passing through number of trays, initial concentration of carbon dioxide, number of plates, or number of trays. Based on that, make use of the K constant, we can calculate how much carbon dioxide concentration is there after treatment. Tower with counter current flow of air and water. The flow of fluid will be two ways. One is co-current, another one is counter current. What is meant by counter current? What is meant by counter current? So no one is there. Oh God. What is meant by counter current? What is meant by co-current? Co-current means what? Counter current means what? Anything wrong, I am asking? Hello? 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 What is meant by co-current? What is meant by counter current?
Against the flow probably is the counter current, and along the flow will be the co-current.
Okay, very good. Somebody is responding. Really, I thanks, sir. Thank you very much. One person is responding to you. I feel very happy. Yes, it is correct. Actually, the flow of two fluids are in the same direction. It is called co-current. The flow of two fluids are in opposite direction are called co-current, counter current. Here we are talking about the water and air. In this particular type of aerator, the water falls down from the top of the tower, while air is coming from the compressor that is passes from the top. So this is called counter current flow, where the air water molecules are interacted in the middle. Then aeration is taking place, unwanted things will be removed and the gas water will be collected at the bottom. Next one is diffused air erector. From the name itself, we can understand that the air is being diffused into the aeration process. This is one of the commercially used type of aerator. This type of aerator normally consists of concrete tanks with a depth of 3 meter to 5 meter width and a 3 meter to 10 meter length to give the desired detention period, which is from 5 to 30 minutes. 15 minutes being common. Normally width to depth ratio is around 2:1 or less than that also. Here the air is injected through the porous plate at the bottom, either throughout the width or along one side of the length, or sometimes the people are suspended the diffuser tubes along one side of the length. But whatever it may be, the satisfactory results are obtained with the spiral flow basins when diffusers are located at 1/2 the water depth, thus reducing the required air pressure. The air requirement is normally from 0.4 liter to 1.2 liter of air per liter of water. The power requirement for this rate of airflow is from 0.3 to 1.3 kilowatt per 100 meter per hour capacity. And a compressor with a high capacity at low pressure should be used because the air to be compressed should be filtered so that dust does not clog the fine pores of the diffuser. And oil from the compressor sometimes finds way to diffuser tray, which can be prevented by providing the oil trap. This is very commonly used type of aerator. It is commercially used for industrial application also. Sometimes people are using spray type aerator also. What is meant by spray type aerator? The spray type aerators, which spray droplets of water into the air from stationary or moving orifices or nozzles. So because of that, the whirling motion imparted to the droplets makes for turbulence at the air-water interface. And they normally stationary nozzles and orifices are used for water treatment purposes, while moving distributors are in wastewater, that is trickling filter condition, they are using the same time. These nozzles make on a slight angle, say between 2 to 5 degrees vertical, since inclined jet trajectory gives longer path and the access of air compared to the vertical jets, which gives largest time of exposure. So the air-water interface is interacting quite a long time, so the exposure time is more. So the aeration process will be more effective in this type. This is also commonly used in industrial application. For this type, they have given some sort of mathematical expression in your book. That is to find out design of spray aerator, and also the expression they have given for the time of exposure of this air and water in the aerator. How to calculate they have given. Just to go through it, if people have any doubt, please you can approach. For the same thing, diffuser type, they have given some other expression to find out the formula they have given for the area of interface per unit tank volume, how much it could be calculated, they have given. And also how to find out the power requirement for treatment of that mentioned quantity of water in the particular type also, they have given an expression. So this is about the aeration process. This aeration process is one of the important steps in water treatment. If the water contains lot of dissolved gases and minute organic particles, to reduce them to some extent, this will be used. People, instead of treating this drinking water treatment, many industrial process, industrial wastewater or effluent treatment, this aeration process or aerator are being used. There the organic waste are coming along with the wastewater. There the use of this aeration process or aerator are required. This is about aeration. Shall we continue or shall I stop? Hello. Can I continue?
Okay, madam.
What we'll do?
I think we can conclude, madam, now.
Okay, I have concluded. I am asking either continue or wind up. Then you people have any doubt, please ask me.
Madam, once again, co-current and that one explain, madam.
Co-current counter. If two fluids are flowing in an opposite direction, that is called counter current. If two fluids are flowing in a same direction, that is called co-current. Now we are talking about air and water, both are fluids. If water coming from the top, air goes from the bottom, they are in opposite direction, that is called counter current. If normally the water will come in the pipe that comes along with the air, that is for co-current. Understand?
Okay, ma'am.
Then any other question? By the end of the class, you people are becoming more active, isn't it? No, you would have told me, ma'am, we'll start up after half an hour means I would have started. No. Actually, whatever I have explained, it is very, very important in your exam point of view. About acid rain, definitely one question will come. About aeration, theory of aeration, importance of aeration, limitation of the aeration, that also one question will come. That the entire unit, sometimes they will ask us a single question. Any more? Hello. I'm asking you people only, but you people are not at all answering. You're critical people. Shall I wind up? Shall I wind up? Okay, thanks to every one of you. Bye. Oh God.
Thank you, ma'am.
Thank you. Thank you very much.
Thank you, ma'am.
Thank you.